Hey everyone, today we're going to discuss about another data structure which is said to be linked list, called as linked list. Firstly, we should follow our tradition. We should give a heading of the thing we are going to study. Okay, I think our last video was on array. Okay, now I am trying to create videos on the topic which are linked to each other. Now linked list is more about, you will see, you can thought it as an array, but there are some main important differences between these two, which will make linked list more efficient than array. So in today's whole video we're gonna discuss about whole these differences. The I can say the idea of understanding linked list is to first understand the arrays. If you haven't yet understand arrays, go watch my previous video. And if you are good to go on arrays, then you just have to refer it with arrays and consider some changes which arrays, where array lacks, there we have to study linked list. Now we will get a quick overview of what the arrays was. Arrays were like they stored data in memory in a contiguous blocks. Very bad drawing. Like this, if you have to store 1, then 2, then 3, then here 4. But what was the limitations of array? Arrays are of fixed size. The size cannot be changed. Once you have created a array of fixed size, then you have to stick to that size. But you can use dynamic array, but else, other than this, you can use a dynamic array which will use inside memory block. The dynamic array works like this. If you have an array of like these 4 elements and you have to add one more element here, what the dynamic array will do, it will create a new array of the double size of it. Like this array was of size 4, then dynamic array will create a new array of size 8. 1, 2, 3, 4, like this. And here it will insert a new element and these boxes will be wasted. Is this method efficient? It is never. So here we have the concept of linked list, which says you are creating a list of elements one after another, which are connected with one after another. You are creating a list in such a way that the elements are one after another. These are in blocks. Like this. These elements are also in blocks. Here the number of elements which are also called as nodes can shrink and grow according to their demands or dependencies. Nodes or elements. Here each node is made up of two things. Each node is made up of two things. One is the data or the value which the node will hold, and other is the reference or a pointer which will point towards the next node, like this. Same goes for upside, same goes for the next. This will also hold the address of the next node. A very much simple concept, but the last node will refer to null. The last node will refer to null. The entry point of any linked list, is called as head, and the last point is said to be tail. Okay. Now again, as the arrays were not only the data structures, they were the abstract data types. Like them also, linked list is another ADT. It is also an abstract data type. How is it an abstract data type? Because of its main operations, which are insertion and deletion. We only do insert. If we have to insert, we will access a linked list and add another element. If we have to delete, we will just access the element and delete the element. We will not go behind or at the back end of it, how the elements is being stored in memory, how it is adding or how it is being deleted inside the memory. So this data hiding process is known as abstraction, and the data types which use abstraction are called as ADTs, abstract data types. Now here are some disadvantages of using a linked list. If we prefer using linked list other than array, I should type here, I guess, linked list versus array, and increase its size to it. If we use linked list versus array, there are some of the disadvantages of using linked list. What are the disadvantages? They are of complexities, time complexities. While accessing an element in array, the time complexity was constant, right? We have stated this in detail in the last video. But while accessing an array in an element in linked list, the time complexity becomes of n, because you are traversing to n number of elements n times. If you are not able to get this, just let me explain to you in a more clear way. While accessing an array element in an array, you will just type its index, you will access it by its index. You will not traverse from start, and for suppose you have to access 4, you will not traverse from 1 2 3 to 4. You will just have the index of 4 and you will access it. So this becomes constant in case of array. But in case of linked list, you have to first start from the head, then traverse until you find the your targeted element. So here the time complexity becomes of n, linear time complexity. And another issue of this is arrays are contagious in memory blocks. So the one element is the neighbor of another. They will be in sequence wise continuous order in memory. But in linked list, what this is, they are just simply hard to manipulate. Linked lists are said that they are hard to manipulate because if you have to delete the last item, if you have to delete it, you will first have to erase this its value, then you have to change the previous one's pointer and point it towards null for making this the last element. So this is again one of the complex thing if we compare it towards the array. What else can be what other things can be, what other operations can be compared between arrays and linked list are indexing. While accessing through index, arrays time complexity becomes O of 1 constant, but linked list became O of n. Other than insert and delete, if you want to insert or delete any element in the beginning of a linked list, the complexity of a linked list become O of n. not in the linked list, the complexity becomes O of 1 constant. If you have to insert element in the starting, then you don't have to worry about where the element is pointing. You just have to point towards it. It will obviously point towards the next element. You just have to insert the value, then the complexity will become O of 1 while inserting in the beginning. But while inserting in an array, the complexity becomes linear, O of n. But here in linked list, the complexity becomes O of 1. Now if you have to insert any element in the last of the linked list, so here the time complexity becomes O of n. Here linked list and arrays have the same time and complexity values. For deleting or inserting in the end and deleting any element, the linked list and arrays have a common time complexity. Now there are some types of linked list, which is singly linked lists. Again have to increase its size. Now what does a singly linked list mean? It means, let me create a table here. Again, imagine this as your list. Now this is what we have. This list is similarly what we have discussed previously. There will be a one pointer which will have address of the other pointer like this, and other part will have the value, will contain the value. As simple as this. One more thing, the difference I forgot to mention in early. Linked lists are always stored in heap memory. The elements of linked list are always stored in heap because linked list is dynamic because of its dynamic size, while array is always stored in stack memory because it is static in size. So array is stored in stack memory. This is one of the key difference. Yeah, I will write array. Okay, so this is simply a singly linked list. Each single element is linked to the other element, and there are two parts. One will contain the value and other will contain a pointer which will point towards the next element, and the last element will point towards null, 0. Now here is the twist of if you have to insert an element in a linked list at the starting, then what you have to do, you will create simply just here one more block where you will insert a 0 element and then a 1 pointer which will point towards 1, which will point towards the other element. Simply here you will need only one pointer, 1p. But if you have the same linked list, okay, I will draw another linked list here. How to write on it? If you have the same linked list, 1 2 3 4 5 6 and 7. Now if you have to add a new element in the end, you will just simply add an element and change this pointer towards the new element and add another pointer which will point towards null or 0. Here you will use two pointers. So this is a very much simpler and easy thing, but I can say important thing to mention about. Now here comes another. Now what if you have to insert in an element in the middle, like here you have to insert 8. You will just add here 7, 6, 5, 4, 3. You will change this this pointer to point towards 3 and this pointer to point towards 4. Here you will also modify 2 pointers. This was a simple concept of inserting an element in linked list. The similar concept has been followed in via deleting linked list in singly linked list. Now the other thing, now the other type of a linked list is doubly linked list. Here we can navigate in both sides. Like if I again draw another table, another linked list, this time I will create a short linked list. Suppose here are 4 elements. Now each element will have, here you can navigate from both sides. Imagine this as this. Here you can navigate from left and also from right, or we can say here you can navigate from head or tail. But in singly list, what you have to do is you have to navigate from left and go towards right. But here we are more simplified, so we use here uh, let I make one more. Oh my god, so dirty drawing. Now there is one, there will be a one pointer pointing towards next element and other pointer pointing towards null. There will be other pointer, one pointer pointing towards previous element and the other pointer pointing towards null element. This is simply what our doubly linked list means. All operations in both these linked lists are very much of same. There is nothing more change. You will insert each element in doubly linked list like the same way. For inserting at the start you will have to use one pointer, in the end you will have to use 2 pointers, and in the middle you will also have to use 2 pointers. Now here comes the another type of linked list, which is circular linked list. Now you have a linked list here. How is it a circular linked list? Let us draw a circular linked list. Listen, one main difference between this type, the previous two linked list you seen, they were somehow pointing towards null values, right? But the circular linked list don't have any null value, no null value. Its start or head start is equals to end, because this will point towards 1, 1 will point towards 2, 2 will point towards 3, and 3 will point towards 4. This is how a circular linked list is created. While coding circular linked list, you have to be very focused. Otherwise, you will run the loop till the infinity. This will keep running. You have to focus on the ending point of any linked list, of a circular linked list. Your CPU uses this type of linked list for doing several processes at the same amount of time, like Robin Hood algorithm, which you don't have to learn now. This is one of the complex topic which you will learn in machine language. Now, final part of the video is to code a linked list, understand how these linked lists are implemented in code. I love coding, but particularly for linked list, I hate typing code of it. You will see why. First, let us start by creating a class which is named as node. Here, remember one thing, here we haven't created a public static void method or a public class firstly. Or wait, we can do, firstly we should create a class for this, like to avoid this. Here I have also created a public main method, but we are leaving it here. And now what we have to do, we have to create another class before the public class, which is named as node. Okay, now in a node we are creating a variable named as data. The other thing we are doing is creating a pointer which is named as next. Now what we have simply done here, we have created a variable named as data, and other we have created a node next, which is a pointer which will point towards the next element of our list. Then in node we have created a int data. We have accessed this, and this is a built-in method which is named as this, which is used to access any element, any particular element of any method or any class you have made. You can access by typing simply this dot data and assign any value to it. So here we have done what we have done, this dot data equals to data, and this dot next is equals to null. Simply you can understand the logic is similar. For if you are initializing a for loop, you will initialize I equals to 0. So like the same ways, you have to initialize the next, you have to initialize a list pointer, so you will initialize it by null. Okay, now what else you have to do is create another node of head. Wait, node head. Right, void insert int data. Now we are creating a method for the insertion at the end of the list. Okay, so here we are creating node, new node equals to new, and node and data. What I have done here, we have created a void method, another method in which we have created a new node in the data. Then we are saying if head equals to null, then here return. Now what here we have done, we have just created a insert method, which will in that we have created a new node. Before we were having a node named node, so we can't name this. You can name it as node 1, but I have named this as new node. Then coming back, you can create a node, a temporary variable. You will use a temporary variable to move the head. You won't move head towards it. Wait, I will explain it to you. You want traverse your head pointer in the list. You will create a temporary variable equals to head temporary variable temp, which is equals to head, and the temp will move and will contain the same value as of head. So what basically means, your value is moving but your head pointer is not moving. This is meant to be creating your code more enhanced. Now here we have to run a while loop which says temp.next. if temp is not equals to null, then we have to do temp is equals to temp.next, right? Temp.next equals to new node. Now we have to create another method which will display the linked list. Till now we just have created the list. We haven't yet inserted any element into our list, and nothing will be displayed here. But now we're gonna create a new method which will simply display the elements of our node, of our list, or we can say display all the nodes. While temp is not equals to null, same logic. So we will not do here ln temp.data plus this arrow is said to be used between two elements of a linked list. This is a basic representation. When keep in mind, whenever you create a linked list, temp equals to temp.next, sorry, temp.next. So it will point towards the next variable. Now you will just do print here null. The last element should be point towards null. Now what mistake I have done is I have created a public class here. I just have to create a main method here, and the public class should be always at the top here. Okay, we will fix this later. Now in the main method, what we are going to do is we have just create a linked list equals to new linked list. Okay, it is a constructor, and now this is a built-in method of inserting elements to the list. You can insert here any value, 10. Once again do the same, list.insert, and insert the value like 100. Once again you can do this, list.insert, and insert the value like 1000, and you can go as far as you want. Wait, let me show you. Copy, Ctrl V, Ctrl V, Ctrl V. Now 2, 3, 4, 5. Okay, now just simply we will run this. What just happened here? We are not getting any our code is being executed, but we are not getting the display. I think what if I run this now? It's still the same. Let me check. What the one simple thing I was missing here if was list.display, calling an simple built-in method to display a list. Oh, here comes. This is the output of our list. So this was the code of a simply linked list. Now if we want to access, if we want to create a double linked list, then what will be the code for this? Let us see. Should I erase this all? I hope you all got this. We will simply create a class, or we can like create a public class to make you remember. Public class linked list, a public static void main method. Then we will drop it down and come and create other things. We don't have to, the same mistake I am making again. We have to drop the main method, not the class, and we have to code from here. Like, I just take time moving the cursor because I don't want to get any indentation errors. Now static class, we create another class node. Okay, right. Now in this node we will have a previous and next pointer. Understand? Because this is a doubly linked list. One thing I am skipping I forgot was to create a int data where our data will be stored, where our integer values will be stored. Okay, now again let's see node int data, right? Now this dot data, we will call this function equals to data. Now this dot previous is equals to null because we are initializing this. This dot next is equals to null because we are also initializing it. Wait, why this is showing error? We'll, I think there is no use of this, that's why it is showing error. Or the mistake I am making is of this. Yeah, right. There is an extra comma. Now node head has to be closed and we will start inserting at the end, right? We will create another method void insert int data node equals to the same thing, new node, the start and the end node, new. Sorry, here we will write new node and data, right? Now if head equals to null, then head will be equal to new node. Okay, if you don't know the difference between these double equals to and this single equal to is these where we whenever you use these double equals to, that means you are comparing two values, and if you are using a single equals to, that means you are assigning a value. Here you are assigning head equals to new node, the value of new node you are assigning to head, but here you are comparing if the head value is equals to null or not. So this is a difference between that. Here I have to put a return condition. Now after the return I have to create a temporary node which will move my head's value while temp.next is not equals to null. Okay, not temp equals to temp dot next. Temp dot next will be equals to new node, and now new node, wait, new node dot previous will be is equals to temp, because we have to link the middle value with the previous one and to the next one, so we have to link both sides. This is a doubly linked list. I was saying it dumbly. Now we have to create a display method, and what we will do, void display node temp equals to head, right? Now another while loop, temp is not equals to null, the same logic. What you have to do is system.out.println temp.data and plus. Now for representing a singly linked list, you will use these kind of first less than sign, then a slash, not slash, then a, what is this called, dash, then a greater than sign. Now temp is equals to temp dot next. Now again system.out.println and null for our last pointer. Now in our main method we will just simply create a linked list equals to new linked list. Okay, then why it is giving us error? Why? Is there any particular mistake I have made? No. We can remove it. Public we will check it on later. First what we have to do, what the simply thing was remaining was to insert the element in our list. You can add here 10. Now I will just simply do copy and paste. Okay, 60, 50, 40, 30, it will be fine. Now I have to just list dot display, simple as that. Now what is the error here? I am getting a vibe that I have given some of these brackets somewhere wrong. Yeah, the class is ending here. The class should end here. I think now it is good to go. If you run this, yeah, now this is our doubly linked list. So this was today's video. I really hope you will not be able to code this by just seeing it once. You have to practice it a lot. You have to watch this code section again and again. By the time you will be perfect in this, but I don't think so you really need to be a pro on linked list. There are more other topics than this where you can invest your time and your energy, utilize it in the best way. I will suggest you that don't waste your time, too much time on this. Just understand the logic and practice it once or twice, and that's it. Move towards the next topic.